Hello everyone, welcome to my YouTube channel. Today we are going to solve some MCQ problems aiming for 2025 board examination which is coming, and this is part 2. The link of the part 1 will be in the description box. So let's start. So question number 1 is saying for any 2 cross 2 matrix, if A multiplied by adjoint of A, this is equal to 10 0 0 10, then date of A equal to what? This means date of A, determinant of A. So given that A into adjoint of A into adjoint of A, this is equal to 10 0 0 10. Taking determinant both sides, so date of A multiplied by adjoint of A, this is equal to date of this matrix, so this is 100. So what is date of A into adjoint of A? This is determinant of A into determinant of adjoint of A. This is equal to 100. So this is a 2 cross 2 matrix, and the determinant of adjoint of A, this is equal to date of A to the power n minus 1. What is n? N is the order of the matrix, 3 cross 3 or 2 cross 2, whatever. So this is n minus 1. So this is equal to date of A into date of A whole to the power 2 minus 1, because this is a 2 cross 2 matrix, that is equal to 100. So date of A whole square is equal to 100. That implies date of A is equal to 10. So option number C is correct. Next problem. Question number 2. A equal to cos theta minus sin theta cos theta. If A transpose plus A equal to I 2, then what is theta? So this is A. What is A transpose? This is cos theta minus sin theta, and this is sin theta, this is cos theta. So A transpose plus A, this is equal to 2 cos theta 0 0 2 cos theta. So this is equal to I2. That means 2 cos theta equal to 1. That means cos theta equal to half. So from this, theta equal to 2n pi plus pi by 3. That means C option is correct. Next problem. The function fx log x to the base a is increasing in R if a is less than 1, greater than 1, greater than 0, or from 0 to 1. So we can use the application of derivatives. So what is f dash x? F dash x is 1 by x into 1 by log a to the base e. This is the chain rule. Okay, so fx is increasing, that means f dash x should be greater than 0. That means 1 by x into 1 by log a base e should be greater than 0. And in the definition of log, x should be greater than 0. That means this is greater than 0. So we have to make this thing greater than 0. So that means log a to the base e should be greater than 0. That means a should be greater than 0, because e is 2.71 something, this value. That means log a to the base e should be greater than 0. Okay, so a should be greater than 0. That means D option is correct. Next problem. 4. If a equal to a11 a12 like this matrix, and ci is the factor of aij in a, this is cofactor, this should be cofactor, then what is the value of determinant a? So this is a11 into c31. So if we multiply an element with another cofactor, that should give us 0. Okay, and like this, a12 plus into a32, a13 into a c33. and A1311 C11 A12 and C21, this is not correct. A21 C11, this is also not correct. A11 C11 A21 C21 and A31 C31, this should be correct. Because if we multiply an element and with it any cofactor of any other element, and if we expand it, then it would be 0. Okay, next problem. The order and degree of the differential equation d square y dx square plus dy by dx whole to the power 1 by 4 plus x to the power 1 by 5 equal to 0. So d square y dx square, this plus x to the power 1 by 5 equal to dy dx whole to the power 1 by 4. Now multiplying by to the power 4. So this is d square y dx square plus x to the power 1 by 5 whole to the power 4, and this is dy by dx to the power 1. So for this would give d square y dx square whole to the power 4 and other terms. So here the highest order of differentiation is 2. Highest order is 2 and the degree of the highest order is 4. That means A, 2 4 is the correct option. The order is 2 and degree is 4. Next problem. If area of a triangle is 35 square unit with vertices 2, -6, 5, 4 and k 4, then k equals to what? So we know that if the vertices is x1 y1 x2 y2 and x3 y3, then the area is half of x1 y1 1 x2 y2 1 and x3 y3 1. This is determinant, and this is the mod, the absolute value of this determinant, because area is positive. So half of this is 2 -6 1, this is 5 4 1 k 4 1. Okay, so this determinant half of mod 2 into 4 minus 4 and minus and -6, that means plus 6. This is 5 minus k plus 1 into 20 minus 4k mod. So that is equal to half of 30 minus 6k plus 20 minus 4k. So that is mod. This is equal to half of 50 minus 10k. So this is equal to half of mod 50 minus 10k. This is equal to 35 given. So 50 minus 10k, this is mod, equal to 70. So from this 50 minus 10k equal to 70 and 50 minus 10k equal to minus 70. So why we have taken these two values? Because this is mod. So that is why we have taken once plus 70 and once again minus 70. So 50 minus 70 equal to minus 10k plus 10k, that is minus 20 equal to 10k, that is k equal to minus 2. And from this minus 10k equal to minus 120, so k equal to 12. That means k equal to 12 and 2. That is option D is correct. Next problem. Question number 7. A is this and B is this. Then and AB is equal to I3. Then what is x plus y? So what is A? 1 0 0 2 1 0 x 0 1. This multiplied by 100 minus 210 y01. So multiplying this, one row and column, 1 and 0 0. Next, first row second column, minus 2 plus 2 and 0. Next, first row third column, y plus 0 plus x. So this is equal to I3, 1 0 0 0 0. So that means x plus y. This is first row third column and this is first row third column. So x plus y is equal to 0. That means A option is correct. Next problem, 8. If A and B are two events such that P of A equal to 0.4, P of B equal to 0.8 and P of B condition A is 0.6, then what is P of A union B? So P of B condition A, this is equal to P of A intersection B divided by P of B. Okay, B, because P of A intersection B and P of B intersection A, this is both are equal. So this is P of B condition A is 0.6 and P of A intersection B we don't know, and P of B is what? 0.8. Okay, that means P of A intersection B is equal to, sorry, this is P of A. Very sorry. This is P of A. This is P of A. So this is 0.4. So that means 0.24. So P of A union B, this is equal to P of A plus P of B minus P of A intersection B. So this is equal to 0.4 plus 0.8 minus 0.24. Okay, that means 1.2 minus 0.24, 0.24. That means 6 and okay, 9, 0.96. So that means option number B is correct. Next problem, 9. Let A vector and B vector be two unit vectors and alpha be the angle between them. Then alpha plus A vector plus B vector is a unit vector if alpha equal to this. So A vector is unit vector, that means mod A is equal to 1 and mod B is equal to also 1. Then what is A plus B vector? This will be a unit vector and this whole square equal to mod of A vector square plus mod of B vector square plus 2 of mod of A vector and B vector into cos alpha, and alpha is the angle between them. And you can write this as A vector plus B vector whole square, or A vector plus B vector dot A vector plus B vector. Okay, same thing. So this is equal to 1 plus 2. This is 1 into cos alpha. So this is 2 plus 2 cos alpha, and this whole square, this is also 1 square. So 2 cos alpha equal to minus 1. That means cos alpha equal to minus 1 by 2. And for this, alpha equal to 2 pi by 3. So option C is correct. Next problem, if alpha a vector and b vector are two unit vectors, then the greatest value of this expression. So root 3 mod a vector plus b vector, this is equal to root 3 into root over mod a vector square plus mod b vector square plus 2 mod a mod b cos theta, where theta is the angle between a and b vector. Okay, so this is equal to root 3 into root over 1 plus 1 plus 2 cos theta. This is equal to root 3 into root 2 into 1 plus cos theta. Root 3 common, root 2 common, root 2 root over 1 plus cos theta. This is root 6 into 1 plus cos theta, and this is equal to root 6 into 2 cos 2 cos theta by 2. Okay, so this is equal to root 2 cos theta by 2, that is equal to root 12 cos theta by 2. Okay, next, a vector minus b vector mod, this is equal to root over a vector square plus b vector square minus 2 mod of a vector mod of v vector cos theta. Again, theta is the angle between these two vectors. So this is root over 1 plus 1 minus 2 into 1 into cos theta. So this is 2 minus 2 cos theta, that means equal to 2 root over 2 into 1 minus cos theta. Again, this is root 2 into root 2 cos theta by sin theta by 2, that means 2 sin theta by 2. Okay, so here we have got, this is 12 root 12 cos theta by 2, and so root 3 mod a plus b vector plus mod a minus b vector, this is equal to root 12 cos theta by 2 plus 2 sin theta by 2. And whenever we get some expression like this, a cos theta plus b sin theta, this expression has minimum value root over minus root over x a square plus b square, and maximum value root over a square plus b square. Okay, so for this will be less than root over root 12 square plus 2 square, so that is equal to 12 plus 4, that is root 16, that means 4. So this expression has maximum value 4. So option number C is correct, 4. Next problem. Question number 11. The linear inequalities or restrictions on the variable of a linear programming problem are called A constraints. Okay. Next problem. Problem number 12. Integration 0 to pi by 2 ln tan x. So this integration is a peculiar integration. Okay. And I will try to make a separate video for some peculiar integrals where I will solve some integrals which are not common or which are standard and often we use the results. So for this integral the answer will be 0. Okay, and try 0 to pi ln tan x. Okay, try it home and tell me in the comment section what will be the answer. So next problem, Problem number 13, dx by x square plus 2x plus 2. So dx by x square plus 2x plus 2. So we will make this term a whole square term. So dx by x square plus 2x plus 1 plus 1. This will be a whole square term. So dx by x plus 1 whole square plus 1. So this is something x square plus 1 square, that is x square plus a square form. So that means tan inverse x plus 1 by 1 plus c. So that is tan inverse x plus 1 plus c. That is option number C is correct. Next problem. Problem number 14. The graph drawn below depicts what? So if you can see, this is minus 1 comma pi and this is 1 comma 0. So if we put x equal to minus 1, then what is tan inverse minus 1? This is minus pi by 4. So this is not pi, because here this is minus 1 comma pi. So what is the value of f of minus 1? That is pi, and here it is f of 1 equal to 0. Okay, so tan inverse minus 1 is minus pi by 4, so this is not correct. Okay, so what is sec inverse minus 1? So sec inverse minus 1 is pi and sec inverse 1 is 0. Okay, so this is correct. And once again, cos inverse minus 1 is pi and 1, and also cos inverse 1 is 0, but this is not correct, because the graph of cos inverse is like this, here, like this. So this is the graph of sec inverse x. So option number B is correct. Next problem. Question number 15. The solution of the differential equation dy dx minus ky equal to 0, y equal to 1 when x equal to 0, approaches to 0 when x tends to infinity if the conditions for k. So try to solve this. Dy by dx equal minus ky equal to 0. That is equal to dy dx equal to ky. So that means dy by y equal to k into dx. Integrating, that is equal to ln y equal to kx plus c. So at x equal to 0, y equal to 1. That means k into 0 plus c. This is equal to ln 1. So that is equal to c equal to 0. So ultimately we are getting ln y equal to kx. Now this is equal to ln y by x equal to k. Now it is said that the solution of the differential equation approaches to 0 when x tends to infinity. So when x tends to infinity, ln y by x tends to 0. That means k should be 0. Only then ln y equal to kx will be 0, tends to 0. So A option is correct. Next problem. Question number 16. The maximum value of z equal to 4x plus 3y if the feasible region of an LPP is shown in the figure below. So these are the corner points. Okay, so z equal to 4x plus 3y. So at z equal to 0 comma 24, this is equal to 72. Z 16 comma 16, this is equal to 64 plus 48, then 102, and z 25 comma 0, this is 4 into 25, 100. So z max is 102 and it is attained in 16 comma 16 point, and the value of it is 102. That is none of the options is correct. Next problem, question number 17. The function fx equal to box x is continuous at. So if you know the graph, this is 0, 1, 2, 3, 4. So this is 1. If you know the graph, the box x function, which is the greatest integer function, the graph of this is look like this. This is from 0 to 1. At 1, this is 1, and before 2, this is also 1, and again from 2 to 3, this is 3, and like that. So this is also called the step function, and you can clearly see that this is continuous at every point except the integers. Okay, so that means this is 1.5 and here it is continuous like this. So option number D is correct. Next problem. So question number 19 is assertion reason based question. So if x equal to 280 and y equal to 80 square, then d square y by dx square is constant for all t. So we will check this thing. So x equal to 280 and y equal to 80 square. So this is dx by dt. This is equal to 2a, and dy by dt. This is equal to 280. So now dy by dx, according to chain rule, this is dy by dx in dy by dt into dt by dx. So that is equal to, what is that, 280 by 2a, that is equal to t. Now d square y by dx square, this is equal to d dx of dy dx. Okay, so this is equal to d dx of t, because dy dx equal to t. So this is 1 by dx by dt, that means 1 by 2a. Okay, so d square y by dx square, this is equal to 1 by 2a, and this is constant for all a all t. So the option number A is correct. Now if x equal to ft and y equal to gt, then d square y dx square is what? So x is equal to f of t and y is equal to g of t. Now what is dx by dt? This is equal to f dash t, and dy by dt, this is equal to g dash t. Now dy by dt, dy by dx, this is equal to dy by dt into dt by dx. This is the differentiation of implicit function. Now this is equal to this is g dash t divided by f dash t. Now again d square y dx square, this is equal to d dx of g dash t by f dash t. Okay, this is equal to d dt of g dash t by f dash t into dt by dx. Okay, so this is the u by v rule. So this is f dash t whole square, f dash t into G double dash T minus G dash T into F double dash T into dt by dx, that is equal to F 1 by F dash T, 1 by F dash T. So we are getting this is equal to whatever in the numerator, this is F dash T whole cube, and see here in the denominator it is whole square, F dash T whole square. So reason is not correct and assertion is correct. So option number C is correct. A is true but R is false. Please observe this differentiation, how I differentiate these implicit functions. This is some parametric form, x and y in parametric form, in uh, it is in another variable t, and how to deduce the dy dx, and after that the d square y dx square. Please go through it once again and you will understand that. So next problem, question number 20. Assertion relation R equal to P comma P on the set A equal to PQR is an equivalence relation, and R is saying the relation R equal to P comma P on the set A PQR is symmetric and transitive but not reflexive. So this is true, because if R has to be reflexive, that means P comma P, Q comma Q and R comma R should be there. This is the main condition for being reflexive. For all x belongs to the set, x comma x should be in the relation. So this is not reflexive, but this is symmetric and transitive, because P comma P and P comma P is in the R, that means symmetric. For transitiveness, if you find AB comma BC, then you will see AC belongs to R. Here you cannot find AB and BC, so this is trivially transitive. So this relation R equal to P comma P is symmetric and transitive but not reflexive. So that means R is correct, and as this relation is not reflexive, it is not a equivalence relation. So assertion is not correct, it is false. So option number D is correct. A is false but R is true. So that's it for today. I hope you understand all the problems. If you understand, please give a like and share it, and I will bring another video very soon. Till then, bye bye. Thank you.